All right, now we're going to move on to problem number 2 right here. So we want to draw the position versus time graph, or sorry, we have the position versus time graph, and we're going to describe the motion of the object. And we're going to keep that pretty straightforward. I'm going to actually go ahead and write that out as simply as I possibly can. So here's what's going on. First of all, when we look at the object here, we see that, whoops, what we see is that this here is steep. We see that this is flat here. So what that tells us is we start by slowing down. We also know that we're going down on the x-axis, so that means we're going backwards. And then we go from flat to steep again. And so what that means is that we're going forward near the end. So when we put all that information together, this is what we end up getting for our description of the motion of the object. It's going to actually look like this. So the object starts at t equals 0, going backwards quickly. Notice I did not say speeding up. And then slows down and turns around at 2.5 seconds and continues forward, speeding up. Excellent, so that's that. Now we want to draw the velocity versus time for this object. And what's going to basically happen with that is that we will start off backwards at a fast speed, and then we end up going forwards, speeding up, and we actually stop here in the middle. So basically what this tells us is right here is 2.5 seconds, and that's how we end up getting this stuff here. So that's how I'd want to get that labeled. Notice all of this is negative velocity. It slows down, it stops, and then it continues going forward at a faster and faster speed. Now we want to know, did the object travel further during 2.5, 0 to 2.5, so from here to here, or from here to here? When did it go further? And of course, when we take a look at this, what we realize is that the object, and just to kind of make this nice, we'll say that the object actually traveled the same distance. We know this because it started and ended at the same position. And that's how I would say that. And then for this last part, we want to know, is the object moving faster at the beginning or at the end? So to get that figured out, we actually look at the graph, and what we see is, although this is backwards and this is forwards, the slope, the steepness of the slopes are equal. So what we can say is the object is moving at equal speeds at the beginning and the end of the trip. The slope are the same steepness, though at the end it is going forwards and at the beginning it is going backwards. That would be the most complete answer that you could write to this problem. So that is the solution to problem number 2.